Now let's look at this figure 14-16, and it deals with the apparent power and how you obtain the power factor based upon this. Now, in the illustration at the very top, see we have 800 watt true power, and we have 800 VA apparent power. Do your math to find the power factor, it's 100%. That's good. Now, you know, all the calculations in the National Electrical Code in accordance with 220.12a, informational note. I'll say that again, you can look it up, 220.12a, informational note. Everything's taken at 100% power factor, so all your calculations come out, you know, based upon 100% that you see right there. Sometimes people say, well, James, you didn't figure this, you didn't figure that, you didn't figure power factor. No, you're not supposed to figure that situation without, you know, the problems there. But now notice a circuit with high power factor, 800 watt true power. But now notice you have 2000 VA apparent power. Doing your math, power factor is equal to the watt divided by the VA. 2000 into 800 watt, 40% power factor. That's bad because that means if you had 480 volt, you'd have to multiply that by 40%, and your conductors sizes would be very large, see. So you'd want to bring that power factor up. How would you do that? Well, again, if you're interested in it, the book, Stallcup's Generator Transformer Motor Compressor book, shows you how to figure this and raise that power factor, you know, using a condenser bank or capacitors to do the job, depending on what it is and where it's located, you know, and that kind of thing. So basically then, this figure 14-16 is going over a circuit with high power factor, how you calculate it, and a circuit with lower power factor and how you'd calculate that. And then, of course, if you wanted to study it further, you can go into it in a deeper manner and see what power factor, when it's poor, what it'll do to you. You take in Fort Worth, if they haven't changed it, the utility required 95% power factor. And engineers had to see to it that they got that, or the utility to put in condenser banks to raise that power factor up to a value that or higher, and would charge monthly for those condenser banks, or the engineer would have to do that. So they would have to prepare in such a way to correct poor power factor. And that's what this figure 14-16 is showing, is how to determine the power factor is illustrated.